So we've been working with similar polygons and similar triangles. Now we want to turn our attention to identifying similar triangles. So us determining if the triangles are similar, not being told. And we've seen some of these types of theorems used back when we did congruence. So we'll see a lot of similarity between the congruence theorems and these similarity theorems. So our first one, we have AA, similarity, angle, angle. If two angles of one triangle are congruent to two angles of another triangle, then that's enough to determine that the triangles are similar, and we can write a similarity statement. So again, AA, similarity, two angles from triangle 1, congruent to two angles from triangle 2. That's enough to say that the triangles are similar, and we can work from there. Once we know they're similar, we can write a similarity statement, and we can solve for missing segments because we know things are going to be proportional. SSS, similarity, side, side, side. That means that we tested all three sides and proved that they are proportional or do have the same scale factor. So what you can see in our work here, I'll highlight it in yellow, we're testing the corresponding parts. Now we can do this, we know that we can set up proportions multiple ways. This is just a three-part proportion where the numerators all came from the same triangle and the denominators are the corresponding parts. So in this case, up and down, each fraction are the corresponding parts. But the numerator is all from triangle 1 and the denominator is all from triangle 2. We can see that they all reduce, and this would show us that all the corresponding pairs of sides have the same scale factor. If this is a reduction, it's 1/2, and if it's an enlargement, we would take the reciprocal 2. But this is showing us that there is a common scale factor. It's not focused on direction, enlargement, or reduction. One way it would be a 2, the other way would be a 1/2. But it shows that there is a common scale factor, and it is important we must test all three sides. It is SSS similarity, so we test all three sides. We can do this in two separate proportions as well. So let's look at another way to do this one. We can set up a proportion, for example, 4 and 8, 6 and 12. When we cross multiply, we get 48 equals 48. So these two pairs of sides are proportional. Proportional. Those two pairs of sides are proportional, but we need to test the third side. So we did 4 and 8, 6 and 12. Now we have to test with the 5 and the 10, but we have to reuse another pair. So for example, reuse the 6 and 12. We get 60 equals 60. Again, that worked. So now our third side is proportional. So we must test all three sides, either for scale factor or set up two proportions. To test it. Because we can only test two pairs of sides at a time. We have to test that third pair for SSS similarity. And next we have SAS similarity, side angle side similarity. So two sides are proportional and the angle between them are congruent. And you can see the work here. We're testing AB and its corresponding side DE with BC and its corresponding side EF. Since they both have the same scale factor, we know that they are proportional. We also could have cross multiplied. So we could cross multiply. When we do, we get 180 equals 180. So that means that they are proportional. So that confirms two pairs of sides are proportional, and then angle B and E, the angle between them, so side, angle, side, the angles are congruent, and we have proportional or similar triangles. So with a little practice, let's fill in our blanks here. Triangle MON, we're going to finish that with triangle GHI. In number 2, this is a 3-part proportion. Now we can only work with 2 of those fractions at a time, but the way it is set up, triangle 1 is across the top, so we're going to fill in triangle 2 across the bottom. MN, going from angle 1 to angle 3, corresponds with the 10. ON, going from angle 2 to angle 3, corresponds with 12. MO, going from angle 1 to angle 2, corresponds with the 8. Now, we're going to name those in this question. Since they gave us the names, we're going to fill it in with names. So rather than those numbers, we're going to use those numbers to solve problems. But rather than those numbers, since they gave us names, we're going to fill it in with names. So MN, we want to fill it in with GI. ON with HI. And MO with GH. So knowing them in the picture is important, but naming them is equally important. And we want to name those in corresponding order. Number 3, let's see which parts we're using. So we're using the 16, the 12, the 10, and we should observe that the 10 corresponds to X. So left over right, 16 over 12, X over 10. I'll write that in red so it stands out a little bit. That's going to be an X. And we can solve that, because that's what we have to do in number 5 rather, is solve that. 12x equals 160. So we'll divide. Um, 16 over 12, x over 10. 160 divided by 12 is 13.3. For number 4, I'm going to erase those highlights. So for number 4, we're using the 12 and its corresponding part, 16. We're solving for y, so its corresponding part is 8. So this time they went right over left. Right triangle over left triangle, 12 over 16. So we're going to go 8 over y. And of course, we'll cross multiply that. We get 12y. 16 times 8 is 128. And when we divide that by 12, we get 10.7. We're asked to determine if those triangles are similar, and if they are, write a similarity statement and explain our reasoning. So, number 13. First of all, we're missing some angles, so we want to find those missing angles, or at least enough to know if these are similar. So in the first triangle, we have an isosceles triangle. Base angles are congruent. We can now find our vertex angle, angle M, because we know the three angles have to add up to 180. And we find out that angle M is 38 degrees. Now that's enough. Since it's an isosceles triangle, the legs stayed congruent. So it doesn't matter what happened from the first triangle to the second triangle. It looks like it got smaller, but those two legs got smaller using the same scale factor because it stayed isosceles. So we have a pair of sides that are proportional to a pair of sides, and we have the angle between them. So this is SAS similarity. And we can say something like triangle NMO is similar to triangle QRP. Those base angles are interchangeable. In number 4, number 14, sorry, we have a 30, 60, 90, our first triangle. And our second triangle, the only thing we know is the 90. We don't know any other angles. We don't know anything about any sides. We do not have enough information. We're going to say not similar. We know the first triangle is a 30, 60, 90, but we do not know the second triangle. In number 15, we started with an equilateral. We ended with an equilateral. So whatever was done, this is showing us that there's a common scale factor. We don't know it, but whatever was done, it was done to all three sides. We also know that since it's equilateral, it is equiangular. All of our angles are 60, and that is true in both triangles. So we can say SSS similarity, or we can say all angles equal 60 and use AA similarity. It's whichever way we can explain it better. Let's look at number 16. Find a few missing angles. So right away, we know that this is perpendicular. Let's find that last angle in the bottom triangle, or in the left triangle. And we find out that there we go. Sorry about that. We find our missing angle to be 28 degrees. Well, that's enough. We have 90 and 28. 90 and 28. These are similar by AA similarity. And we can write a similarity statement. For example, A, B, E. So 28, 90, 62. We're going to match that with 28, 90, and what must be 62. So DBC. In number 17, we have vertical angles. But we also have parallel lines. So we have some vertical angles. And now, since we have parallel lines, we have alternate interior angles. That is enough for us to say a similarity. And we can write our similarity statement. For example, YWX is similar to YVZ. In number 18, we have two triangles. One triangle is inside the other. So look at this as a small triangle and a big triangle. The small triangle is inside of it. We have angle S, which is part of both triangles. So we always look for what they share. Remember, with congruent triangles, we look for the segment that they share. With similar triangles, we're looking for the angle that they share. It's just that one is smaller than the other. One triangle is smaller than the other. Again, parallel lines, so we have to think about our angle pair relationships. And for example, we have corresponding angles. Well, again, that's enough to say a similarity. And we can write a similarity statement. For example, the small triangle, STR, is similar to the bigger triangle, SUQ. We can look at a few more examples here. We're just going to determine if these triangles are similar. So I need to find a missing angle. We know the angles add up to 180. So in the first triangle, our missing angle is 31. In our second triangle, our missing angle is 47. We do not have enough information to say that they are similar, so we're going to say not similar. In number 11, one equilateral triangle became another equilateral triangle. All three sides were affected the same way, same scale factor. So this is SSS, similarity. In question 12, we're going to test it. So from the big triangle, I have 6 and 8. From the smaller triangle, 3 and 4. When I cross multiply, they are proportional. So we have the pair of sides and the angle between them. So that's a similarity. But we have to test those sides. Number 13. We want to see if we have enough information. We definitely have the 90 degrees. But do we have enough information to say that the triangles are similar? Well, we don't have any more information, so we're going to say not similar. In 14, we're looking at isosceles triangles. Now, the two legs stayed congruent, so they're definitely proportional, but we have to test the base. So we can test something like 9 over 6 and 6 over 4. Leg over base. 36 equals 36. That's true. And the legs are all proportional. The legs are definitely proportional because both of those legs are 9, both of those legs are 6. So we can test it if we wanted to. We would basically get 9 over 9 equals 6 over 6. So we tested and verified all three sides. That's SSS similarity. Again, we should verify, we should test it. We could do the leg over leg, leg over leg, and we verify that they really are similar. In number 15, I don't know why it says 30 factorial. That makes no sense. It should just be 30 degrees. So we do have side angle side. Similarity. I have no idea why that. I don't know what happened on the print. Let's see if we have any more here. Okay. We want to determine if these two triangles are similar. Notice it is one small triangle inside of a big triangle. So we do have angle A is shared by both triangles. So we have 52 and angle A. And then from the big triangle, we have 52 and angle A. So this is AA similarity. Triangle AEB is similar to triangle ADC. We're given the 26 for angle C. We can certainly find our missing angle in this triangle is 64. So again, we have AA similarity. And maybe something like triangle CDE. So 26, 90, 64. KGH. Okay. Again, one triangle inside of another. So we need to find some missing angles. So in the small triangle, we're going to do 33, 85 and the missing angle. So 33, 85 and X. And we get 62 degrees. So now we have 33 and 62. And then from the big triangle, 33 and 62. So we have AA similarity. One triangle to the other. So on the big triangle, BAD. The little triangle, corresponding order, CED. Let's see what we still have here. All right. We certainly have our vertical angles. So we're going to test our sides. Now, we don't know if this was just flipped over or reflected and enlarged, or if it was kind of twisted, reflected again, and then enlarged. We don't know. So we have to test this. We have to try this out. So I'm going to try it. For example, 16 and 9. And I might try 27 and 18 and find out that it does not work. 6 times 18 is 108. 9 times 27 is 243. So that didn't work. But I might have to deal with alternate interior angles. So this is really not the way to do it. What we want to think about are the idea of alternate interior angles. So the 6 over 9 really corresponds to 18 over 27. And then we can say these are proportional. So this is a little bit of a challenge question because we don't know if that top triangle was just reflected. In this case, they didn't show it to us, but these lines are really parallel. So angle M corresponds to angle K, alternate interior. Now, again, what makes this a challenge question is that they didn't show us the lines were parallel. We had to try it. So that made it a little bit more of a challenge. In our next example here, what I might want to do is draw this as two separate triangles. So I have the little triangle, 4 and 3.5, and then I have the big triangle, 12. I got to add the two segments together. And 10.5, again, adding 7 to 3.5. But they both use angle C. So angle C is in common. We need to test those two sides. 4 over 3.5, 12 over 10.5. And we're going to test this. So we're going to cross multiply. 10.5 times 4 is 42. 3.5 times 12, times 12 is 42. These are proportional. They share angle C, so this is side angle side similarity. And now we can say angle CBD is similar to triangle CAE. Triangle CBD is similar to triangle CAE. So unlike congruence, we actually have to do a little work to figure out whether they're similar. But the idea of testing all three sides or two sides and the included angle stays with us. A few more here. In our first example, we have angle 52 degrees and 52 degrees. And then angle A is shared. So we have AA similarity. We know angle A from both triangles, and we know 52 from both triangles. Remember, we don't need to know what angle A measures. We just need to know that it's the same on both triangles. And of course, we can write a similarity statement. For example, AEB and ADC. Very similar to a previous question, and now we're a little bit wiser. So we focus on our vertical angles. And again, even though they didn't tell us that they're asking us to figure this out, and they didn't tell us that we have parallel lines, but think about parallel lines and alternate interior angles. So I'm going to test, but that means that the 30 corresponds to the 18 because they're alternate. So E and B are alternate interior angles. So that means 9 corresponds to 15. 18 corresponds to 30. So I'm going to test 18 over 9, 30 over 15. And I get a scale factor of 2. Or I can cross multiply. 270 equals 270. So this is SAS similarity. Triangle CBA is similar to triangle CED. Again, these are a little bit more challenging because we're testing, not assuming those angles are congruent. We have numbers for all 3 sides, so we want to see if these are proportional. Small with small, medium with medium, large with large. I can even label it small, medium, large, small, medium, large. So I'm going to test the small and the medium. So from triangle 1, 8 over 12. From triangle 2, 6 over 9. 72 equals 72. These are proportional. Now I have to test the large. So I'm going to reuse either the small or the medium. You have to reuse it. So let's say the mediums are 6 over 9. I'm sorry. I did small over medium, not left and right. I did small over medium. Small over medium. Triangle 1, triangle 2. So we're going to do the same thing, except with medium and large now. So I'm going to do medium over large from triangle 1. That's 12 over 16. And from triangle 2, medium over large would be 9 over 12. And we're going to cross multiply. 144 equals 144, so that worked. SSS similarity. And now we want to name those triangles in corresponding order. So let's see if we do ABC. Then we're going to match it with DEF. And in our last example here, we have parallel lines. So again, we have vertical angles and alternate interior angles. So we have AA similarity, triangle VRS, similar to triangle VTU. So we have to test proportionality to see if those triangles are similar. When triangles are similar, the sides are proportional. Are the triangles similar? Is asking us, are the sides proportional? So we test them. And that's how we can determine AA similarity, SSS similarity, and SAS similarity.